What do you know about a square? 4 equal sides, okay.
4 90-degree angles.
4 right angles, okay. And then it gets you here. Now, one of the things that you can do with a square is that you can connect from one vertex to one across via a diagonal. So what we do is we look at what's called a diagonal. If I draw that diagonal in, it creates two right triangles. It creates two congruent right triangles. You okay with that? Now, the type of triangle that's created is pretty obvious. You've got two sides that are the same. So it creates two what type of triangles? No. Isosceles. You get two isosceles triangles. If you have an isosceles right triangle, it means that those two side lengths are looking at the two base angles that are the same. Remember the rule. If sides are the same, angles are the same. What do those two base angles measure? 90? What? What? I couldn't hear you. What?
The top one and the bottom one.
Yeah, they both make 90, and they're the same, so what do they both measure? 45s. Yeah. Yeah, these two are the same, but they both measure 45s. That's where the term, this is where the term 45, 45, 90 comes into play. So what I do here is I write this out. Across from the 45, that means you're at this 45 degree angle, you're looking at the side opposite you. This 45 degree angle is looking at the side opposite you. This 90 is looking at the side opposite. Well, what we need to do is figure out side lengths. So we start with something easy. Since this is an isosceles right triangle, if one side length is 4 for the leg, what does the other leg have to be? 4. Okay. Now, what would you use to solve for the hypotenuse? Pythagorean theorem. Yeah, a squared b squared. Okay. So I would say, excuse me, 4 squared plus 4 squared is our c squared. You okay with that? 16 and 16 is how much? And then how do you undo squaring? I just made it up. If I take the square root of this, what do you get? 4 root 2. Good. So if my side lengths are 4, my hypotenuse is 4 root 2. What happens if my side lengths are x? If my side lengths are x, you get x squared plus x squared is c squared. You okay with that? What's x squared plus x squared? 2x squared. Good. How do you undo squaring? Square root. Now, do you guys remember last year when we did radicals that you can break this into two of them? The square root of 2 times the square root of x squared. Remember that? Do I know what the square root of 2 is? But do I know what the square root of x squared is? What is it? X. So this will always be your hypotenuse. What happens here is that you get this basic pattern. No matter what 45, 45, 90 triangle you get, you always have the same pattern to it. Across from the 45 is some value of x, which means across from the other one is some value x, which means across from the 90 is that value of x times the square root of 2. So if I change this to 14 and 14, If I type that in my calculator, 14 squared plus 14 squared, hit enter. Take the square root of it, what do you think you're gonna get? Yeah. Yep. It is a quick pattern that happens within special right triangles that'll allow you to eventually build stuff for trig. Because you'll know that's a 45-degree angle and certain things happen within all 45-degree angles. And we start to look at this more and more as you get into Algebra 2. Speaking of Algebra 2, you guys, let's start back up. Anyway, so what happens then when we have these special right triangles for this 45, 45, 90? Remember, you can show that something is a 45, 45, 90 by one of two ways. Sometimes it can be marked up by just showing that it's an isosceles right triangle, that it's implied that it's 45, 45, 90. Or the other way is sometimes it'll show that it is with the congruent base angles. But no matter what, each and every one of these follows the exact same pattern. And what I do is I set up what's called an algebra jig. Excuse me. If any of you have ever had to make multiple cuts, whether it's lumber for like banisters for railings or anything like that, what you would use instead of remeasuring something out over and over again, you would make something called a jig. And what I mean by that is, if I have to make something that's, if I have to cut a bunch of wood that is going to be 33.5 inches long each and every time, I'm not going to waste my time taking the tape measure, marking it, then cutting it. Tape measure, mark, cut. What I would do is I would build something. I would build a little box with a 2x4 and a stop. And I would make sure that this measured what I needed it to be, 33.5 inches. And I would make that work. Then I would take the piece of lumber, slide it in here where it stops, and I would cut it here, slide it in again, cut it, and so on and so on. That way I'm reusing something that's pre-measured. I'm reusing what's called a jig, okay? They use those for making pre-cuts. They use them for when you put handle knobs on drawer fronts. There's all these pre-made things so you don't have to remeasure. That's a jig. Same thing with the algebra. If I take this algebra jig and I know that I have 45, 45, 90, and I know that one of my side lengths is 8, I just have to know across from what angle is the value of 8. Well, it is across from the 45. So that means across from the 45 is the value of x. And in this case, that value of x equals 8. Which means everywhere I see an x, I put, and I get the following. That's it. And that's it. It's a matter of understanding which side length you know. If you can figure that out, you know everything else. Now, the weird part of this comes in sometimes when you're given across from the 90. And this time, let's say it's equal to 10. There's no root 2 next to it. Is that okay? Yeah. You do the exact same thing. You know that across from the 90 is the value of 10. So that has to equal that. I need to figure out what x is. X times the square root of 2. How do you undo multiply? Divide. So all I have to do now is take my calculator out and divide 10 by the square root of 2. And the calculator gives you what's called a simplified radical form. What do you get? You get 5 root 2, which means that's playing the role of x, so that goes here and here. So my other two side lengths are then 5 root 2. That's all this is. At most, these types of problems are a one-step algebra problem. And divide by the square root of 2. That's it. That's it. Use this algebra jig. Set it up, reuse it over and over and over again. Okay. The other triangle that we talk about, besides the 45, 45, 90, comes from the equilateral triangle. What do you know about an equilateral triangle? All sides are equal. If all sides are equal, what do you know about all the angles? They're all equal. What do they measure? 60, good. So all the angles are 60, all the sides are the same. So let's make this really easy. Let's say we have a side length of 8. That means all my sides are 8. Okay with that? Now what I want to do is draw an altitude. An altitude is the segment from a vertex to the side that is perpendicular. Okay? Fix this for a second. So if it's perpendicular, it creates a right angle, which means then this is 90, this is 60. What is this little angle up here then? 30. Very good. Now, what that altitude does, it bisects the angle, but it also bisects the side down here. So if this whole thing is 8, these two sections become 4s. And you get this pattern of a 30, 60, 90. Now, take a look at the two sides that we know. I know the side opposite the 30 is 4, and the side opposite the 90 is 8. What did you have to do from the side of 30 to get to the side of 90? What is it? Oh, instead of adding, what are you doing? All right, how much? We just doubled it. We just doubled it. So what happens here is you get some value of x, and then across from the 90 would be double that value. But how do you figure out that missing side length, that across from the 60? Gee, you know two sides of a right triangle. How do you find the third? Pythagorean theorem again. So if I do that, if I know that 4 squared plus something squared is 8 squared, excuse me, what's 4 squared? 8 squared. Okay. Subtract that over, I get x squared is what? 48. And then how do I find the square root of 48? I square root it. I press some buttons. What's the square root of 48? What's your calculator say? 4 root 3. So what do you think I'm going to put in place of across from the 60? 4 root 3, but notice, if that's got a 4 root, this was 4, that's 4 root 3, and that's 8, all it was something times the square root of 3. So your two patterns then. And it's going to be really easy to decide, to figure out which one is which. A 45, 45, 90 is an isosceles. This one, it has to tell you that you have a 30 and a 90 degree angle, or it has to tell you that you have a 30 and a 60, 30 and a 60, or a 90 and a 60, you'll be told, you have to know what angles you'll have. It'll be very, very easy to figure out which is which. So, across from the 30, some value of x. X times the square root of 3, and 2x. These are our two best friends for this, what we call algebra jig. You're going to reuse it over and over and over again. Excuse me. Show you an example. So we have a right triangle. We have a 30-degree angle, a 90-degree angle, which means it has to be a 30, 60, 90. And I know across from the 90 is 22. So all we do is this. We start at the beginning. Across from which angle do you know? The 90. Across from the 90 is equal to some value 2 times x. Well, in this case, that 2x is playing the role of the number 22. So we set it equal to, what is x? 11. Which means everywhere I see an x now, I'm going to replace it with, so across from the 30 is 11, and across from the 60 is 11 root 3. That's it. All it is. You figure out which triangle you have. Across from what angle do you know? What's that? You mean 11 root 3? Oh, because that's how much it is across from the 60. The side length will be 11 root 3. Because if you take, check it, if you take 11 squared plus the quantity to 11 root 3 squared, you get 121. 121 times 3, so the 363. I add those two together, we get what? 484. The square root of 484 should be, that's why it works. Because it goes back and forth between Pythagorean theorem. Oh. Oh well. I was getting ahead of myself. Try another. All right. Is this a 30, 60, 90 or a 45, 45, 90?
30, 60, 90.
Why is that? Because there's a 60. Kind of nice. Write out the jig. 30, 60, 90. Across from which angle do you know? The 60. I know that across from my 60 is 18, which means I set this equal to 18. It is a one-step equation. What do you do? No. X times the square root of 3 equals something. How do you undo times?
Divided.
Take 18 divided by the square root of 3. And that's going to give you your value of x. 6 root 3, very good. So if that is the value of x, everywhere I see an x, what do I put? 6 root 3. So across from the 30 is going to be 6 root 3. Across from the 90 is going to be 2 times 6 root 3. Well, what's 2 times 6 root 3? 12 root 3. And there you go. We're using simplified radical form. These are exact answers. There's no decimals. There's no decimals. Okay? Let's try another one. So I have 2 values. Well, I'm sorry. I have 2 sides that are the same, which means it's going to be what kind of a triangle?
45, 45, 90.
45, 45, 90. We write it out. Across from which one do you know? 90. And again, when you put that in the calculator, it simplifies it out for you. You get this value of x is going to be 13 root 2 over 2. That's the fractional amount that it is. That's what the calculator says. Unfortunately, yours doesn't. It doesn't simplify the radicals. You're going to want to really believe me that you're going to want to buy that one. You have plenty of, yeah, guys, this is the main reason why I kept harping like all year. Say, hey, make sure you get this one because you're going to need it. You're going to need it. Which is, which is fine, is that even if you don't have it right now, you can still set up everything. And you can just convert it later. You know, you can still do all the work and you can ask her, hey, can I press a couple
Right
buttons?
now, I'm just using the multi-view calculator online.
Oh yeah, that works. That works. I didn't know they had one online.
Yeah.
That's cool. It does the radicals too? Nice. Very nice. So that just means that across from here, you're 13 root 2 over 2s. It is nothing more than substituting in. Honestly, I don't think that there's any possible way that I can make this more straightforward. And it all stems from you have to write those out. Yes, ma'am.
How come you have to put it over 2?
Because when you simplify the radical, if you take in your calculator, you take 13 divided by the square root of 2, what's your answer?
Oh, I did it multiplication.
No.
Okay, yeah.
You have to undo it. Remember, you're solving that one-step equation. You have to divide by the square root of 2. Yes, ma'am.
I'm so confused on the, like, the x square root of 2. Like, how do you know that it's not easy?
It always is. That's the rule. Across from the 90s is something times the square root of 2. So if you know what value, in that case it told you it was 13, you take 13, you set it equal to,
Oh, if this
yeah.
what would the same thing with the 30, 60, or 90? Is that something different?
I can't hear you. What?
Is that the same thing that goes with the 30, 60, 90, or is it?
It's one or the other triangles. You have to figure out which one's which.
Oh. 30, 60, 90. You have to know we have one of
Yeah, I got 12. Easy killer. Guys, as I said, I cannot stress this enough. You need to write these down on there, and for every problem, rewrite it. One of 2 things is going to happen. First thing is you'll probably get the answer right. Second thing, it'll force you to memorize it, because you have to know these special patterns. Okay? Excuse me. Oh. Yes, please. Oh, I'll get from. Oh, sorry. Why would I start learning how to count? Numbers are fun too. You know, I didn't take that class in college.
Wait, so it was 20?
Yes, ma'am. Yeah, you can do all the work on a separate sheet. I mean, honestly, what I would do on this one, hey guys, what I would do on this one, because there is plenty of space here, I would just say, hey, I'm going to write down my first one. I have a 45, 45, 90. So I'll write 45, 45, 90, x, x, x for 2. Draw my arrows. What do I know across from? And fill in the blanks. I would do that every time. It just forces you to do it that way. It forces you to actually learn it by doing a little bit extra work, to be honest with you.